going to move on to integrals involving tangents and secants. So if you think about this, though, we're going to try to do the same thing as we did with the sines and cosines when we could. We're going to want to make a u substitution. So let's remember, if I take the derivative of tangent, I'm going to get secant squared. Whoops, that's a 2. And if I take the derivative of secant, I'm going to get secant tangent, right? That's what I need to get. That's what I will get. So the substitution that you are going to do is going to depend on the form that you have, right? Because if I want to have a du that has a bunch of secant squareds in it, I have to have an even power of secant, like that. And if I am going to have a du that's secant tangent, then I need to have an odd power of tangent so that I can pull one off. Okay? Because all right, so that's sort of, let's just think of that for a minute. And just kind of keep that in mind. So you can see for this first one, I have a secant squared dx right here. So I almost don't even need to do anything here. I can just go ahead and straightforwardly do a u substitution. So why I put this one? Oh, because I didn't write it up. It was supposed to be this. Ha! Like, why is it? That's easy, right? So it was supposed to be this. I still want to do a u substitution the same way, right? I want to make u be my secant squared, but now I have more than secant squared there, right? So what I have here is secant to the 6th. So what I'm going to do is I'm going to pull off secant squared and keep that for my du. Okay? So that's going to tell me that what I want to do for my u substitution is I want u to be tangent, and then du is going to be secant squared. Okay? Now, what after that? So now I know that my u is going to be tangent, so I have to change these secants to tangents. And of course, there's a formula for that, right? Now, if you're like me, you always forget that formula. Well, I conveniently put that formula on your sheet for you. However, I don't have that sheet. It's somewhere, wherever, on my computer that died. It's somewhere there, whatever. So if I have to remember it, I don't have to think about it, because the sign, this one's easy, sine and cosine, but the other one, it's always like 1 minus or minus 1 or something, so I always forget it, where the minus goes. So it's very easy, if you forget your tangent secant formula, it's very easy to come up with it from the standard Pythagorean identity. We know we want tangents, right? So tangent is sine over cosine. So I just divide this whole thing by cosine squared, right? And that gives me my identity that I want, which is tangent squared plus 1 equals secant squared. See, this is the part I always forget. I always forget if it's plus 1 tangent or plus 1 minus 1 or whatever. Anyway. So, but it's that. So if you see me forget and try to remember by doing something like this, that's what I'm doing. And this is the form. This is very nice. I want secants. So you're just going to put this in here. So let me just go ahead and substitute tangent squared plus 1 for my secant squared. And I have a secant to the 4th, so that's secant squared squared, right? And then I have secant squared x dx. Now everything is tangents except for my du. I can go right ahead and put this all stuff in here. So I have u to the 4th u squared plus 1 quantity squared du. And okay, I just have to do a little bit of algebra, right? But this is nothing too bad, right? This is very straightforward. And now I'm going to proceed down to here. Hopefully we can see that, okay? So I end up integrating u to the 8 plus 2u to the 6 plus u to the 4th. So 1/8 u, I'm sorry, 1/8, 1/9, 1/9 u to the 9, 2/7 u to the 7th, and 1/5 u to the 5th, right? And then I want to put back what u is. So then I just get my final answer in terms of powers of tangent. Here, and then last one is 1/5. Tangent to the 5th plus c. Oh, okay, plus c. The plus c was off the screen. Well, there's a screw there. Okay, so you got to have your plus c. So that is an example there. Now notice that we made that choice precisely because we had even secants. Okay. If I had odd secants, okay, so remember, because I need to use the Pythagorean identity, so everything has to be even. If I have odd secants, I hope I also have odd tangents. So let me give you an example there. Oh, actually, this is odd. Okay, let's do odd. Tangent 3 secant 5. Odd. So while I erase, you can kind of think, okay, what's the good thing about odd? The good thing about odd is that if I make u be secant, my derivative is secant tangent, so I can pull off a secant and a tangent there, and that'll be my du. And then I'll have an even number of secants left, so that u will be my secant. All right, so what I just said, I'm going to write it down. This is going to be tangent squared. This is going to be secant 4. And then I'm going to take one of each of those. Secant x, tangent x, dx. And I'm going to make this be my du, so I want u to be secant, because the derivative of secant is secant tangent. I'm probably off the screen with that dx. Oh, almost. Here. There's the dx's there. Okay. Alrighty. So that's what I want to do. I want to make everything secants now. So I had tangent squared plus 1 was secant squared, which means that tangent squared is secant squared minus 1. By the way, you'll notice I'm not saying tangent squared x, secant squared x, only because I'm lazy. And we're just talking here. But when I write it, I always write the argument. If you just write tangent squared or sine squared without the x or 2x or 5x minus 7 or whatever it is, then it's wrong, because it doesn't mean anything without the argument. Okay, so do watch that. If we often just say sine, cosine, or tangent, but when we write it, we have to always write it with the argument. Okay, even if we're writing whole strings of them like this. So as I said, so my next thing, because I want u to be secant, I want this one I'm just leaving for my du, but all the rest of them I want them also to be secants. So I'm going to put this guy in for secant for tangent squared. So this is secant squared x minus 1 times secant to the 4th x times secant x tangent x dx, right? This whole thing is my du. So if I go ahead and make my substitution now, I've got u squared minus 1 times u to the 4th du. Nice and easy integral, right? U to the 6th minus u to the 4th. So I've got 1/7 minus 1/5. And then I want to put back u equals secant x at the end. So secant to the 7 minus secant to the 5th. And there's my answer.